Hello guys, welcome to iPlus Education. This is Sayyed Ismail. In this video lecture, I am going to explain first shifting property for inverse Laplace transform. First shifting property, that is e power of plus or minus at property. We know that if Laplace transform of f of t is f of s, then Laplace transform of e power of minus at f of t will become f of s. Here we have minus a, so we will take plus a. This is the first shifting property for converting time domain function to s domain function, that is using this property for Laplace transform. Similarly, this property can be modified to obtain inverse Laplace transform by just rearranging this L. If we send this L to that side, it will become e power of minus at f of t. Value is L inverse. If we send this L to that side, it will become L inverse f of s plus a. This is the property that we will use here in inverse Laplace transform. By using this property, we will solve one question. Here we have L inverse 1 by s plus 2 whole power of 5. So let us see the solution for this. Now treat this s plus 2 as s for simplicity. Step 1, treat s plus 2 as s. So it will become L inverse 1 divided by s power of 5. So by using this formula of transformation, t power of n transforms to 1 divided by s power of n plus 1. Here we have n factorial. So L inverse of 1 by s power of 5 will be, here we have 5, so take less value by 1, so we will get t power of 4 by 4 factorial. Now the next step is replace s by s plus 2. Here we will use first shifting property. So L inverse 1 divided by s plus 2 whole power of 5. Here in time domain function, we will get exponential function, that is e power of minus 2t due to this s plus 2 into, here we have t power of 4 divided by 4 factorial. 4 factorial is 4 into 3 into 2 into 1. So we have 4 3s are 12, 12 2s are 24. So we will get e power of minus 2t into t power of 4 divided by 24 is the answer for this question. Let us see one more question of inverse Laplace transform. L inverse s by s square plus 4s plus 13. Here in denominator, we have a quadratic equation. Consider s square plus 4s plus 13. We cannot factorize this quadratic equation. In that case, we try to make this quadratic equation a perfect square. So let us convert this quadratic equation into perfect square. We know that a square plus 2ab plus b square, a square plus 2ab plus b square, value is a plus b whole square. So we try to arrange this quadratic equation in this form, a plus b whole square form. So here we have s square, write down s square as it is. Here we have 2. So we can split this 4 as 2 into, here we have a first term, here we have s. So we will take 2 into s. Now this 4 can be splitted into 2. One more 2 is required. So we will take 2 here. So here we have s, 2 into 2, that is 4. So s square plus 4s. Now here we have b. So here we have to take b square. Here we have 2. So we will take 2 square here, plus this is the modification. 2 into 2 is 4s. This and this over and 4s and 2 into s plus this is extra 2 square. Now here we have 13 as it is. Here we have added 2 square. So in order to balance this, we will subtract 2 square. Now if we cancel this, we will get again this s square plus 4s plus 13. So in order to modify this, we are just adding and subtracting 2 square so that it becomes a perfect square like this. Now a square plus 2ab plus b square will become a plus b whole square. So this complete will become s plus 2 square plus here we have 13 minus 2 square value is 4. So we have s plus 2 square, we have 13 minus 4, 9. That can be written as s plus 2 square plus 9 can be written as 3 square. So this L inverse s divided by this can be replaced by s plus 2 square plus 3 square. Now here we have s, here we have s plus 2. Both numerator and denominator should be of the same form. It means that here we have s plus 2, here also we want s plus 2. So we can write down like this, s divided by s plus 2 square plus 3 square. Since we have plus 2 here, what we will do, we will add 2 and subtract 2. Now we can write down it separately. We have L inverse s plus 2 first term, this s plus 2 divided by this denominator s plus 2 square plus 3 square. Now we have minus L inverse 2 divided by s plus 2 square, s plus 2 square plus 3 square. Now let me write down one more time. Take this 2 outside, we have minus 2 L inverse 1 divided by s plus 2 square plus 3 square. Let us take it as equation 1. Now here we have s in numerator, so we can think of cos formula. We know that cos AT transforms to s divided by s square plus a square. Here we have constant 1. We know that sin AT transforms to a divided by s square plus a square. That a can be written as here. Now here we have s plus 2 by s plus 2 whole square plus 3 square. So we can think s plus 2 as s. So this will become s divided by s square, s by s square plus 3 square. That is treating this s plus 2 as s only. Its transform will be cos, here we have 3, cos 3t. Now by using For shifting property, if we replace this s by s plus 2, if we replace s by s plus 2, then we will get exponential term e power of minus 2t into cos 3t. Similarly, here we have 1 by s plus 2 whole square plus 3 square. So we will treat this s plus 2 as s. So 1 by s square, 1 by s square plus 3 square transforms to, here we have constant, so we will take sine, here we have 3t, here we will get 1 by 3 using this formula. 1 by s square plus a square is 1 by a sine 80. Here we have s plus 2, so replace s by s plus 2, we will get s plus 2 square 3 square. Whenever we replace s by s plus 2 or s plus a, we use for shifting property. Here we will get exponential term e power of minus 2t into 1 by 3 sine 3t. Now writing down here, L inverse s plus 2 by s plus 2 whole square plus 3 square, value is e power of minus 2t into cos 3t. Here we have minus 2 into, its value is e power of minus 2t into 1 by 3 sine 3t. So the final answer is e power of minus 2t cos 3t minus 2 by 3. Even we can take e power of minus 2t common. We have cos 3t minus 2 by 3 sine 3t. We can write down directly this step from this. Just think that this is s by s square plus 3 square is cos 3t, s is replaced by s plus 2, so we will get exponential term e power of minus 2t. Now this is the end of this question. Let us solve one more question. We have L inverse 1 by 9s square plus 6s plus 1. We have a quadratic equation in denominator with coefficient of s square as 9. But we do not want 9 to be the coefficient of s square, we want 1 as the coefficient of s square. First of all, consider this denominator. Take 9 common, we have s square. Here we will get 6 by 9 into s plus 1 by 9. Here if we have 9 s square plus, if we cancel this, 3 2s are 3 3s are. So we have 2 divided by 3 into s plus 1 by 9. Now we will make this into a perfect square. Since we cannot factorize this quadratic equation, it means that we cannot get two factors easily. So we will try to make this a perfect square. That is, a square plus 2ab plus b square can be written as a plus b whole square. So here what we will do, here 9 as it is s square. Now here we have 2, so take 2 here. Now here we have a, the first term. Here we have s is the first term. Now we have 2 and we have s. What is left? 1 by 3 is left. So we will write down 1 by 3 plus, here we have b, we will take b square. So here we have 1 by 3. So we will take 1 by 3 square. Now here we have plus 1 by 9 as it is. Now we have to add and subtract this term 1 by 3 square. Now this will become 9 into, this is perfect square, a square plus 2ab plus b square. So this will become s plus 1 by 3 s plus 1 by 3 square. Here we have 1 by 9 minus 1 by 9. So these two will get cancelled. We will get this only. So we have 9 into s plus 3, s plus 1 by 3 square. So our question is L inverse 1 divided by this denominator can be replaced by 9 into s plus 1 by 3 square. Taking 1 by 9 outside this L inverse, we have 1 by 9 L inverse 1 divided by s plus 1 by 3 square. Now L inverse of this term can be obtained in two steps by using first shifting property. Since we have two factors, that is repeated factors or repeated factors. So first step, let me solve here. Let us take it as equation 1. Step 1 is treat s plus 1 by 3 as s plus 1 by 3 as s. So this L inverse will become 1 by s plus 1 by 3 is s only. So s, here we have square. So this will become L inverse 1 by s square value is t power of 1 by 1 factorial, that is t only. Now the second step is replace s by s plus 3, s plus 1 by 3. So we will get L inverse 1 by s plus 1 by 3 square. Then here we will get t into exponential term due to this replacement, e power of minus t by 3. So we have t into e power of minus t by 3. Here we have 1 by 9. So substitute this value here. We will get, here we have 1 by 9. L inverse of this value. L inverse of this value we have t into e power of minus t by 3. So this is the solution for this question. Let us see the solution of this L inverse s plus 8 upon s square plus 4s plus 5. In numerator we have a factor, in denominator we have quadratic equation. This quadratic equation cannot be factorized. It means that we cannot get factors of this form. So we have to convert this into a perfect square. Let us see the solution. Consider the denominator, that is s square plus 4s plus 5. Now perfect square means a square plus 2ab plus b square is replaced by a plus b whole square. So try to arrange this in this form. So here we have s square as it is. Here we have 2. So I want to convert this 4 into 2 here. Here we have s plus, here we have b, then we will have b square. Here we have 2. So we have to take 2 square plus, here we have 5. Now we have to take, we have added 2 square, we have to subtract 2 square so that this polynomial is balanced. So now this will convert it into perfect square as s plus 2 square. Here we have 5 minus 4, 1 square. Now we have s plus 8 upon s square plus 4s plus 5 values s plus 2 square plus 1 square. Here we have s plus 2. Here we have s plus 8. We want this numerator to look similar to that of denominator. Here we have 8 but we want 2. So we will modify this as s. First of all, write down the denominator s plus 2 square plus 1 square. Here we have s plus, here I have 2. So I will take 2. Here we have 8. So I will write down 6. So that s plus 8, s plus 8 only. Now we will separate the numerator. We will get s plus 2, this divided by denominator, s plus 2 square plus 1 square plus 6 divided by denominator, 6 by s plus 2 square plus 1 square. This is the value of s plus 8 by, that is s square plus 4s plus 5. Now here I have L inverse, so apply L inverse. L inverse s plus 8 divided by s square plus 4s plus 5 values. Here we have L inverse s plus 2 divided by s plus 2 square plus 1 square plus L inverse. Here we have 6. So let me write down this 6 outside this L inverse 6. Here we have 1. 6 is taken out, so we have 1 by s plus 2 square plus 1 square. Now we know that sin 80 transforms to 1 divided by s square plus a square. Here we have 1 by a. If we multiply exponential term, e power of, here we have minus bt sin 80 by a, then this will become 1 by, due to this exponential term, here s will be replaced by s plus b. So s plus b square plus a square. Similarly, cos 80 transforms to s by s square plus a square. If I multiply exponential term e power of bt cos 80, then this s will be replaced by s plus b. We will get s plus b by s plus b square plus a square. So this will become, here we have s plus 2, s plus 2. In numerator we have s term. So this will transform to cos. So this will become cos. Cos, here we have 1t. Now here we have s plus 2, not s. So exponential term will be there, e power of minus 2t plus 6 as it is. Here we have constant. For constant in numerator we get sine term. Sine, here we have a value 1, so we will get 1t. Here we have 1 by 1 into exponential term e power of minus 2t. Hence the solution is, take e power of minus 2t common, cos t plus 6 sin t. This is the solution. If we take Laplace transform of this, then again we will get this question. So this is the inverse Laplace transform. So you try to remember this transformations. So it will be easy for us to transform inverse Laplace transform. The question given is L inverse s minus 4 upon 4 into s minus 3 square plus 16. Here we have s plus 4, here we have s minus 3. Both are different. Now consider s minus 4 divided by 4 into s minus 3 square plus 16. Now here the coefficient should be 1 of this s minus 3 whole square. So take 4 common, we have s minus 3 square plus 4. Here we have s minus 4, here we have s minus 3. I want this denominator to be same as that of denominator. So what we will do, we can write down this s minus 4 as s minus 3 minus 1 divided by 4 into s minus 3 square plus 4 can be written as 2 square. Now separate the numerator, we have s minus 3 divided by 4 into s minus 3 square plus 2 square. Similarly, we have minus 1 divided by 4 into we have s minus 3 square plus 2 square. Now apply L inverse. That is, our question is, let us substitute here only. We have L inverse of this transforms to s minus 3 divided by 4 into s minus 3 square plus 2 square. Here we have minus sign, minus L inverse 1 by 4 into s minus 3 square plus 2 square. Now take this 1 by 4 outside. We have L inverse s minus 3 divided by s minus 3 square plus 2 square. Here we have minus 1 by 4. L inverse, this 4 is taken out. 1 divided by s minus 3 square plus 2 square. Now this will become 1 by 4. Here in numerator we have s term. For s term, this transform will go into cos. Here we have a value is 2, so this will become 2t. Here we have s minus 3. So by first shifting property, we have e power of minus 3. So we will take plus 3t. Here we have minus 1 by 4. Here we have constant 1. So this transform will go into sine. Sine, here we have 2t. Multiplied to 1 by this 2, 1 by a. Here we have s minus 3. So due to this, we will get exponential term e power of, here we have minus, so we will take plus e power of 3t. If we take common, e power of 3t by 4, common et by 4, we have cos 2t minus 1 by 2, this 1 by 2 sine 2t. So this is the answer for this question. Let us see one more question of L inverse. We have L inverse 1 by 2 into s minus 1 whole square plus 32. Okay, we have L inverse 1 divided by, take this 2 common, we have 2 into s minus 1 square plus 16. Now take this 1 by 2 outside this L inverse, we have 1 by 2 L inverse 1 divided by s minus 1 square, 16 can be written as 4 square. So we have 1 by 2 into, here in numerator we have constant 1. So this will transform to sine. Sine, here we have 4t 1 by 4, 1 by a into sine 80. Here we have s minus 1, that is shifted by s minus a. So we will get exponential term e power of, here we have minus, so we will take plus 1t. So the answer is e power of t sine 4t divided by 2 into 4 is 8. So this is the answer. E power of t into sine 4t by 8. Evaluate L inverse s by s plus 7 whole power of 4. We have repeated factor in denominator. Now see the solution. We have L inverse s divided by s plus 7 whole power of 4. Here we have s plus 7 in denominator. So we want 7 here. So add plus 7 minus 7. So that denominator looks similar to that of denominator. Now separate the numerator. We have L inverse s plus 7 divided by s plus 7 whole power of 4 minus L inverse of 7 by s plus 7 power 4. Now one factor will get cancelled. Here we have only 3 factors. So we have L inverse of 1 by s plus 7 whole power of 3 minus, take 7 outside the L inverse. We have 1 divided by s plus 7 whole power of 4. Take this as equation 1. We know that 1 by s power of n plus 1 will transforms to t power of n by n factorial. S domain to t domain. T power of n by n factorial. Here treat this 1 by s plus 7 as s only. Then here we have 1 by s. Treating this s plus 7 as s only. So we have s cube. So this will transform to t square by 2 factorial. Here we have, okay, replacing this s by s plus 7. So this will become s plus 7 whole power of 3. Then we will get exponential term t square by 2 as it is, into we have to multiply exponential term due to this replacement e power of minus 7t. Here we have plus, we have to take minus 70. Similarly, here we have 1 by s plus 7 power 4. Treat this as s only. So we have 1 by s power of 4. Will transforms to, here we have 4. This will become t cube divided by 3 factorial. Now we have s plus 7. So replace s by s plus 7. We have 1 by s plus 7 power 4 will transforms to exponential term e power of minus 70 into t cube divided by 3 factorial is 3 into 2 into 1, that is 6. So substitute here. L inverse of this value is e power of 70 into t square by 2 minus e power of minus 70 into t cube by 6. Now taking common e power of minus 70, then we have t square by 2 minus t cube by 6. Now here we have 6. So I want to make this as 6. So multiply 3 here. So taking 6 common, we have 1 by 6 into e power of minus 70 into 3t square minus t cube. Even if we take common t square, then we will get, take t square common, we will get t square by 6, t square by 6 e power of minus 70 into t square is common. So we have 3 minus t. This is the solution of this question. This step can be write down directly. Just assuming this as s power 3 is replaced to t power 2 by 2 factorial. Due to this replacement, we will get e power of minus 70. Same here. Assuming this as s power 4 means t power of 3 by 3 factorial. Due to this s plus 7, we will get e power of minus 70. So this is the last question of this topic.